Let's go to example 2 together. And then I'll have some classwork for you to try. So I'll do example 2 and example 3. You get to see it 3 times before you try it yourself, okay? So let's do this. Let's calculate this limit. So for the first limit definition, we have the limit as x goes to, in this case, 3. And we're basically going to have f of x minus f of 3 divided by x minus 3, right? And let's write out what that limit's going to be. We're going to have a 1 over x minus 1 over 3 over x minus 3, like this. So the first thing we should do is we should just try plugging in the number. When I plug in the number, I hope you guys can see we get 0 over 0. So so here's one where we're going to need to do a little bit of work. I can rewrite this as the limit as x goes to 3. Let me put a 1 over x minus 3, and then I can put 1 over x minus 1 over 3 like this. So this means the same thing, but it prevents me from having to write a fraction over, having fractions in the numerator. How do you want to handle this situation? What would be the next thing you want to do? Or what technique would you want to use to calculate this limit? Does anyone have any feeling? Do you want to multiply top and bottom by the conjugate? Do you want to factor and cancel, simplify, take one-sided limits? Not sure. Not sure. Okay. When I look at this, this is something that I call a complex fraction. A complex fraction is a fraction involving fractions. But even if it wasn't a complex fraction, I mean, I don't see there's a lot that we can do besides trying to simplify this. So I'm going to simplify this expression in the parentheses. I'm going to pray that the x minus 3 gets canceled out somehow. Okay. So let me turn off my messages here, so my mom doesn't keep messaging me while we're trying to do this class. If I wanted to simplify here, what's the first thing I need to calculate? What do I need to do to simplify this? Anyone have any feeling there? Oh, common denominator, I agree. The common denominator is going to be 3x. Okay. And what do I need to do to this first fraction to get a 3 on the bottom, 3x on the bottom? I need to multiply top and bottom by 3. So I need a 3 here. What do I need to multiply this guy by to get 3x on the bottom? I need to multiply top and bottom by x. So I got an x here. Makes sense? So then I get the limit as x goes to 3, 1 over x minus 3. Now that I have these under a common denominator, this is going to be 3 minus x over 3x. Does anyone have any feeling as to what I want to do next? Because I look at this and it's like, this is almost that. There's just one thing I can do to make it look exactly right. That's right, Luciano. We got to factor out the negative. So this guy is going to become the limit as x goes to 3. You're going to have a negative 1, x minus 3. When you factor a negative out of the numerator, that becomes x minus 3 over 3x. Now we can cancel out these guys, x minus 3, x minus 3. So you end up with limit as x goes to 3 of negative 1 over 3x. Now I can plug in the 3. I'm going to get that's equal to negative 1 over 9. Does that make sense to everybody? Is there any questions? So we can write the equation of our line. The equation of our line will be y minus 1/3 is equal to negative 1/9 x minus 3, like that. Okay. If we want to write this in y equal to mx plus b form, this would be y equal to negative 1/9 x plus 1/3. That's what I get when I distribute this negative 1/9 over here like this. And then I need to add this to the other side. So when I add this to the other side, 1/3 plus 1/3 is going to give me 2/3. So this implies this. And this is the equation of our tangent line. All right. So I know this one says use each definition. I think I was going to do this one with this definition, and I'll do example 3 with the other definition. Okay. So let's take a look at example 3. For this one, we want to find f prime of 2. Remember, f prime of 2, that means the derivative. So this is the slope of the tangent line. And that's the slope of the tangent line. Okay. So we know that to find f prime of 2, we need to calculate the limit as h goes to 0, f of 2 plus h minus f of 2 all divided by h. And for us, that's going to be the limit as h goes to 0, 3 times 2 plus h squared minus 4 times 2 plus h plus 1 minus, you should probably put parentheses around the second term here because the whole thing is getting negated. So this will be 3 times 2 squared minus 4 times 2 plus 1, like this. Okay. All divided by h. So as you can see, we have a fairly complicated expression in the numerator. When I look at this, I think, oh, we definitely need to simplify. So why don't we simplify all of this stuff down? So we're going to get the limit as h goes to 0. We're going to have the numerator here is 3 times 4 plus 4h plus h squared minus 8. You got to be careful here. I got to distribute this negative 4. So a lot of students will mess this up. They will forget to distribute the negative. So this is going to be times or minus 4h and then plus 1. Does anybody have any questions about how I expanded this first part here? No. And then, like I said, make sure you keep the parentheses there. So this will be 2 squared is 4. 4 times 3 is 12. So this will be 12 minus 8 plus 1, like this. And this is all divided by h. Okay. All right, so let's distribute, and then hopefully a lot of this will cancel out. So we got the limit as h goes to 0. This is going to be 12 plus, we have to distribute the 3 across to all 3 terms like this, right? So this will be 12 plus 12h plus 3h squared minus 8 minus 4h plus 1 minus 12 plus 8 minus 1. All divided by h. So check it out. You got a 12 here, but then a minus 12 there. You got a minus 8 here and a plus 8 here. You got a plus 1 here and a minus 1 here. So all that stuff kind of cancels each other out, which is nice. Okay. So let me make this a little bit more manageable here. So then we end up with, what do you notice? You notice in the numerator, every term has an h left. That means we can factor out the h. So this is going to be the limit as h goes to 0. If we pull out an h from the top, you're going to get 12 plus 3h minus 4 all divided by h. And then when I factor, I can see that the h's are going to cancel out. Now I can use the direct substitution property. So so I plug in a 0 for h. That makes the second term here 0. So you just get 12 minus 4, which is 8. And that's going to be our answer. Does anybody have any questions about that?